is one of my favorite activities in all of our study of earth science. So what I'm going to ask you to do for the rest of this week and into next week is create for me a sedimentary rock. Now normally when we do this project in class, I require that your sedimentary rock needs to be edible. It needs to be something that you could eat because we watch all those geology kitchen videos. But since we're at home, if you don't have the supplies to make an edible sedimentary rock, you can make an inedible sedimentary rock too. So you could use materials you have around the house, you could use things you find outside. That will be okay for this experiment, just don't eat it when you're done. But I'm going to model how to create an edible sedimentary rock. If you have these supplies or other supplies in your kitchen like these, that will work out really well. The requirements for your sedimentary rock are that you have to be able to show me evidence of at least one coarse grain sediment. So examples of coarse grain sediments, remember those are ones that are big enough that they're easy to see, might be chocolate chips or oats, like you would put in oatmeal. And you also have to have an example of a fine grain sediment. Remember, a fine grain sediment is very, very small. So here I have some sugar that I'm going to use in my edible sedimentary rock. Now please don't feel like these are the only supplies you can use. I would encourage you to think outside the box and maybe to only use one of these supplies for my example, as opposed to using all of them. In addition to a fine grain sediment and a coarse grain sediment, you're also going to need a binding agent. You're going to need something that can cement all of these parts and pieces together. And in my example today, I'm actually going to use two different binding agents. I'm going to use peanut butter, which actually, this is the chunky peanut butter, so it's going to have some examples of kind of a medium grain sediment in it as well. And I'm going to use maple syrup. So, my process is pretty simple. The beautiful thing about rocks is that they don't have a definite chemical composition, right? And so I don't have to measure so much as I'm making my rock. The ratio I get is the ratio I get. I'm going to start by adding some coarse grain sediment. There we go. And again, I get to decide how much of each of these things I think make up a good sedimentary rock. I'm going to add a little bit more coarse grain sediment. This is going to be kind of an interesting rock. And then of course I have to have at least a little of my fine grain sediment in my sample as well. Now it's okay when you're done if I'm not able to see the fine grain sediment that you've added to your rock. Remember in those rock samples we looked at in our lesson, like the sandstone, it was kind of difficult to see all of those individual grains in the real rock as well. So here I have all three of my sediments together. Because of the processes that shape Earth, it's reasonable to assume that the Earth is moving and shaking and those parts and pieces are getting slowly mixed together. Now, in order for this to form a sedimentary rock, now I need to add some of my binding agents. Remember, I said that my binding agents today were going to be peanut butter and maple syrup. So here we go, adding our peanut butter binding agent to the rock mixture. If this were a real sedimentary rock, my binding agents would be things like calcite and water. Let's add a little bit more just to make this exciting. And then as my secondary binding agent, because oftentimes in the natural world there's more than one thing holding all of these different compounds together, let's add a little bit of maple syrup. Again, Earth's processes are going to shape this rock. They're going to mix all these parts and pieces together. But even after they're mixed together, they're not necessarily what we would consider to be a sedimentary rock. This is the process of cementation. So this is the process of sticking all these pieces together. But in a really strong sedimentary rock, like the examples of sandstone that we looked at in our video, we have to also have the process of compaction. And so I want to make sure to stress with you that your sedimentary rock should show some evidence of compaction as well. In order to compact my rock, I'm going to take some of my mixture, and I'm going to put it on a sheet of wax paper, sort of fold it over, and then I'm going to press just with my hands. That's enough of the modeling of compaction for the sake of this activity. Now when you're done, you might end up with something that looks sort of like this. Make sure that you take a picture of your work. In order to earn the points for this activity, you're going to need to be able to show me both a picture and in written words, tell me about what you used for your fine grain rock, what you used for your coarse grain rock, and then what your binding agents were, what you used to cement it all together. Now, one quick point before I let you go and get to work. Sometimes students liked the idea of using heat in their sedimentary rock. Remember that the rocks that form from molten material, the rocks that form from heating and cooling, are igneous rocks. So I shouldn't see any evidence of heat in your sedimentary rock sample. Hopefully that's enough to get you started. Have fun. I'm looking forward to seeing what you create.